I'm here today with Ken Tubman, Vice President of Geosciences and Reservoir Engineering for ConocoPhillips. Hi Ken, thanks for being here.
Hey Ray, good to be here.
Now Ken, you've said that geophysics can do a lot, but that the real improvements will come through integration with other disciplines. Talk about integration and what are the disciplines involved and how will that affect the future of the industry?
Okay, it is true that geophysics has really been able to provide a lot. The acquisition technology has improved greatly and we're able to go out and sample a lot better. The algorithms we use for imaging have made huge advances. Putting them together in some areas has really given sharper views of what is in the subsurface, but there's some environments like deepwater Gulf of Mexico, subsalt, where even with the different acquisition and much better algorithms, the images are still not as crystal clear or as non-unique as we need them to be. So here's an example. We're bringing in our geologic concepts, going to geology, saying here's our model. We can bring that in with the algorithms and be able to test. Is it consistent with our interpretations and our thoughts, or is it inconsistent? And so it's a way where rather than using algorithms and just getting one single clear image, we can test multiple hypotheses from the geology. So it's bringing in that case, the geologic example. It can actually go a bit farther than that. Sometimes it's also around iteration. You try something, does it work? No, try again. Or try again makes it even more clear each time you do it, and testing more hypotheses and being able to adapt a bit and have a lot of adaptability in how we approach things.
All right, so you've stressed the need for adaptability. What exactly do you mean by that?
So what I mean by adaptability is really twofold. One is a common thing that happens. We look around in the scientific community outside of geophysics and we see other capabilities and we try to bring them into geophysics and then take advantage of them. Another though is sometimes we develop a capability internal and for one purpose, and we have to be adaptable enough to see where else that could go.
Can you give us some more examples of adaptability?
Sure. A couple of examples we're working on now. One is within ConocoPhillips, we're working on compressive seismic, which is a new way to sample when we're going out and acquiring data. It allows us to get very good images at lower cost and in less time than conventional acquisition. We can work with multiple source vessels and be able to separate them well. And this is an idea that originally came from medical imaging. And so there's a number of people who saw it in medical imaging. There's some consortia working in our industry, and we at ConocoPhillips have already implemented this a couple of times in some field trials. It works quite well. There's a drone technology. We hear a lot about that now, and ConocoPhillips was the first company to use drones in a commercial test. We recently did some work there up in Alaska. And another example of the other, though, where not just taking from one discipline or outside our community into geophysics, but where we give back, if you will. In geophysics, there's been a huge demand for compute power. And so inside ConocoPhillips and other companies, we build these massively parallel computing facilities in order to do our imaging. And what we have found internally is, an example is reservoir engineering, where they have very computationally intensive calculations. They're not as naturally adept at using the parallel nature of our computing, but we have found some ways where that very large compute capacity has really benefited our approach in ConocoPhillips to how we look at uncertainty, how we model our reservoirs, and it's actually let us go into, instead of relying strictly on empirical and decline curve analysis and other approaches, we've been able to go into a much more simulation-based ability to model many of our reservoirs and our uncertainty. And that's something that we were able to develop because of the compute power that came up inside our geophysics group.
Very good. Thank you, Ken.
Thanks, Ray.